This Engineering is Elementary digital how-to will demonstrate the creation and use of the lever station from the unit Marvelous Machines, Making Work Easier. To construct one lever station for your classroom, you will need one set of materials common to all the Simple Machine stations. One spring scale, measuring 10 newtons. One load that weighs approximately 1 to 2 pounds, such as a filled half-liter water bottle. At least 3 feet of string or mason line, and a pair of scissors. You will also need the following materials specific to the lever station. 1 carabiner, 1 dowel, 2 feet in length and 0.4 inches in diameter, 1 wiffle ball, approximately 2.5 inches in diameter, with round holes, 1 plastic rigid safety cone that is approximately 18 inches tall, 1 1-liter plastic bottle filled with water, a permanent marker, a tape measure or meter stick, masking tape, and optionally, sandpaper and duct tape. First, slide the wiffle ball onto one end of the dowel and slide the ball across the length of the dowel, checking that the ball slides snugly. Use sandpaper to sand down any part of the dowel where the ball gets stuck. The ball should be able to move along the length of the dowel. Measure and mark the midpoint of the dowel using the marker. Then, slide the wiffle ball so that it is centered on the length of the dowel. Place a piece of masking tape just to the left of the wiffle ball and wrap it around the dowel. Use the permanent marker to label the masking tape B. Place a second piece of masking tape just to the right of the ball. Use the permanent marker to label this masking tape C. Next, slide the wiffle ball so that it rests just left of the tape labeled B. Place a third piece of masking tape to the left of the ball. Use the permanent marker to label this masking tape A. Once the dowel has the 3 labels for the lever arm lengths, remove the wiffle ball from the dowel. Measure and cut a piece of string that is 2 feet in length. Securely tie and knot this string around the neck of the filled 1-liter plastic water bottle. This bottle will be the anchor that will stabilize the lever arm during use. You can optionally reinforce the knot around the neck of the anchor bottle by wrapping duct tape around the knot and string. Place the 1-liter bottle inside the safety cone. And pull both ends of the string through the hole in the top of the cone. Thread the string through 2 holes in the wiffle ball and attach it to the ball with a secure knot. Making a bend in one end of the string before feeding it through can make this easier. Rest the wiffle ball on top of the cone and push any hanging string inside the cone. This will allow the wiffle ball to pivot above the cone without the string interfering. The 1-liter bottle acts as an anchor for the lever station, suspended from the wiffle ball and hanging inside the cone. Slide the marked dowel through 2 holes in the wiffle ball and center the dowel on the cone. Tie and knot a piece of string on one end of the dowel. You can tape the knot to the dowel to make it more secure. Then, create a loop at the end of string hanging from the dowel. Close the loop by tying additional knots. You can cut off any excess string hanging from the knots with scissors. Attach the hook of the spring scale onto the loop of the string. The spring scale will hang with its ring facing down. At the other end of the dowel, you'll use the same steps to create another loop of string. Try to place both loops about the same distance from the ends of the dowel, so the lever arm is symmetrical. Tie and knot a piece of string to the dowel. Tape the knot to the dowel. Create a loop with the hanging string. Close the loop with several knots. And cut off excess string using scissors. Tie and knot a piece of string around the neck of the half-liter filled water bottle. And then tie and knot a loop with the remaining string. This creates the load for the lever station. Next, clip the carabiner onto the loop of string on the load. Then, clip the carabiner onto the loop hanging from the dowel. The lever arm is used to raise the load 6 inches, but the dowel should never travel beyond a horizontal position. Typically, this means that the string between the carabiner and the load should be about 4 inches in length. We will show you how to adjust the length of string on the load so that the load is raised 6 inches when the dowel is horizontal. First, move the dowel into position A by sliding the dowel inside the wiffle ball until the ball rests just to the right of the tape labeled A. Push down on the end of the dowel with the spring scale, so the dowel is perfectly horizontal. Now, measure the distance between the bottom of the load and the surface holding the lever station. If this measurement is less than 6 inches, the string between the carabiner and load needs to be shortened. If the bottom of the load is more than 6 inches above the surface, the string needs to be lengthened. Unclip the load from the carabiner and remove any tape from the bottle. Adjust the length of string as needed. We are demonstrating how to shorten the string by wrapping and knotting the extra length around the neck of the bottle. To lengthen the string, you could wrap less of the string around the bottleneck and also remake the loop so it is closer to the end of the string. With the string around the load adjusted and resecured, hold on to the dowel again so it stays in a horizontal position. Check that the bottom of the load is 6 inches from the surface when the dowel is horizontal in position A. To complete the preparation of the lever station, mark the 6-inch height that the load will be raised during testing. If the lever station is set up near a wall, Measure 6 inches from the floor and mark the height on a wall with a piece of masking tape. If the lever station is placed on a desk or table, tape a ruler so 6 inches of the ruler sticks up above the surface. Tape the ruler close to the load and against the edge of the desk or table. To use the lever station for testing, the dowel should be moved to the position being tested, and students should use one finger to pull fluidly and straight down on the ring of the spring scale. The readings from the scale should be taken when the load is raised 6 inches. Students should not pull down on the spring scale at an angle or in a jerky manner. They should also not pull down on the spring scale by grasping the body of the scale.